So let's go through exam 4 with question 1. What's the correct answer? The correct answer would be E. But if you did choose A, what would that have given you? If you chose A as your answer, you would have gotten this answer right here. You would have added the HBr right there. If you chose answer B, that's typically done when you want to brominate alkanes. Okay, not with alkenes. HBr and ROR, you would have added the bromine like that. With elemental bromine right there, you would have had this species right here. Let's we would have had a bromine there and then a bromine there. So question 2, was IUPAC name of this species? If we zoom in here, we know that we have to have the alkyne in the longest carbon chain. And so we can trace the longest carbon chain just like that. And how many carbons is there? When we do that, we can number it this way: 1, 2, 3, 4, 5, and 6. So we know our parent name has to have a hexine. Okay, but how we number that is very important, because we want to number it in such a way as to give the alkyne the lowest locant number. And numbering it from left to right would give us the right answer. And so the correct answer of all the answer choices would be E, because we have a methyl and we have 2 methyls right there. Question 3. Okay. Which of the following is an intermediate when 1-butene undergoes radical bromination with MBS and light? So what does 1-butene look like? Looks just like that. And when we have MBS, that's going to generate a bromine radical, which is then going to be used to abstract the allylic hydrogen. So let's actually draw it like this. Like that. So following those red mechanistic arrows there, answer choice C would be the correct answer. Question 4. When you take a look at these reactions, C works, D works, and B works. All are going to give us our product of 2-methylpropanol, which looks like this. Just like that. And so that's the reaction that will not work. Why will that not work? Because Grignard reagents are very sensitive to water and acid. And so if you have a carboxylic acid and you treat that with a Grignard, which looks like this, the first thing that Grignard's going to do is come and grab that acidic proton. And when that grabs that acidic proton, the Grignard reagent has been destroyed or used, and now you can't do anything else. So your product is going to be just a carboxylate. Whoops, not that. Would just be a carboxylate like this. That's what the product would be for A. 7. What is the major product of the following reaction? That's going to put all the chlorines across that triple bond. 4 of them. Question 8. Which reaction sequence best accomplishes this transformation? Well, when you look at this transformation, what have we done? We have added just one carbon. Because if we count 1, 2, 3, 4, 5, 6, 2, 3, 4, 5, 6, 7. So we need to find a reaction that adds a carbon. And so the best answer choice for this one would be A. Identify the most likely initiation step. So you need to understand what initiation step means. And then bromination of methylpropane, which would simply just be this. Not that, sorry. There's our methylpropane, and it said bromination. Okay, so that's Br2. And then we would have to have some kind of light to get that to go. And so when we have Br2, the initiation step is to generate that radical, which would be that step right there. Question 10. 1-methyl cyclohexene. So the product looks like this. Not like that. Cyclohexene ring with the methyl coming off of that. And so the best choice to get to that product would be B. Question 11, a retrosynthesis problem here. And the way I approach this problem is I'm just going to look at this right here. That's all the same, right? That's our target. So I'm going to look at the first reaction. Can I make this turn into that? And the answer is yes, I can. You can take a alkene and do a syn dihydroxylation or or just a anti-dihydroxylation if you want to. So that would work. I'm not showing any stereochemistry, so it doesn't matter. So that would work. Have we seen a species like that turn into a diol? No, we haven't. So I'm like, that looks too suspicious. Haven't seen that in class or in the textbook. Could I take that and go there? Yes, I can. So that one checks out. And then have we seen an enol go to a diol? No, we have not. So now that's off the table. That's off the table. Now I'm going to do, can I turn this guy into this guy? Okay. And so what we see going on here is that we have a alkene tacking on an extra carbon versus a triple bond giving us the trans alkene. And so that answer choice C, we know how to do that transformation in one step. But this reaction right here up top could in theory be done, but it would require multiple steps. And so based off of that, the answer choice C is the most proficient and makes the most logical sense. And then when we take C to double check to see does everything work, do we know how to take an alkyne and tack on one carbon to it? Yes, we do, by an alkynide reaction. So answer choice C is the best answer choice. 12. Of the following, which are the best reagents to perform the transformation? So we see we go from an alcohol to a ketone, and that's a secondary. And then we have a primary alcohol to a aldehyde. And so when we take a look at these things, this reagent, that reagent, and that reagent will both go from this secondary to a ketone, but would not generate an aldehyde. You would generate a carboxylic acid. PCC is the only one that will stop a primary alcohol at the aldehyde instead of going all the way to the carboxylic acid. 13, that bond right here, that allylic position, that's the easiest bond to break. What is the product of the following reaction? Well, here we have to just remember what do alkynes and ozonolysis do? What does that turn into? If we take a look at this carefully, it would chop that bond off. And if that's carbon 1, that's carbon 2. Carbon 2 is going to look like this. That's carbon 2. It's going to turn that into a carboxylic acid. So if we go 3, 4, 5, we would see something like this. Let's go up. 3, 4, 5. And then we would have our methyl right there. And that methyl is that guy. So that's the product that we would expect. And then when you look at the answer choices, alcohol, aldehyde, ketone, aldehyde. None of those work. So the only option here is CO2. But understanding that a little bit better, we see this carbon right here, carbon 1. Carbon 1 is a product, and that turns into CO2. So those terminal alkynes, when treated with ozonolysis, you have a carboxylic acid product and a CO2 product. So that's the only possible answer for that question. So we need to know what that product looks like. If we follow the nomenclature rules, it looks like that. So now we have an alkyne, and we want to turn it into that. So that would require us to have one equivalent of HBr. We can stop it at that product. Okay, question 16. Okay, so let's just draw in the answer choices, or the correct answers here. So we would have to have a terminal alkyne. And then that terminal alkyne is going to be deprotonated and turned into, and do an alkylation event to add those two carbons. So if those two carbons are those two carbons right there. Then if we go in this direction, right here, we have an alkyne treated with mercury sulfate, sulfuric acid. That's going to generate a ketone. Like that. So for that problem right there, that's 2 points, that's 3 points, and that's 3 points. Partial credit would be for this molecule right here, or that answer choice. If you did this and you made the correct enol, we gave you +1. And then if you gave a alkylation event, but your carbon count is wrong, we gave you 1 point for that. Okay, what is the IUPAC name for molecule X? The answer would be R2,2-dichlorocyclohexanol. Like that. And the way we broke down the points for this was that's 3. That part is +2. And that was +3. Draw the major products of this following reaction. We are assessing, do you understand how lithium aluminum hydride reacts with ketones versus esters? And lithium aluminum hydride reduces that to the alcohol and that to the alcohol, all the way to alcohols. And so we would have a primary alcohol and a secondary alcohol. But if we treat that compound here with sodium borohydride, we have to remember that esters are not touched by sodium borohydride. So that will only reduce the ketone into the alcohol. And so this was a all or nothing problem. So that was +4, +4. Question 19 is a mechanism. So we want to see this process right here. We have our sodium amide right here. It's going to come and deprotonate. To generate the alkynide. And then that's going to be treated with the methyl bromide. And we have to extend that bond right there. Like that. To give us our final product. And so the way the points worked was 4 points for forming the alkynide ion. Okay? So if you form that, you got 4 points. You get 2 points for the correct proton transfer step, shown right there. And then you get an additional 2 points for the correct SN2 mechanism, which is shown with those arrows right there. And then the last one, told you what it is. The reaction is Tautomerization, which means we just take the enol and convert it to the keto form, which looks like that. If you drew that product, you got 3 points. And then the mechanism part. And the mechanism would look something like this. We see that we're under basic conditions. So that means we have the hydroxide. And with the hydroxide, we have to find the most acidic proton. So it's that guy. And this is all reversible, right? So now we form this species right there, plus water. And then the next step is we could take these lone pairs here, collapse them down, take that double bond, and grab the proton to give us our final product. Okay. Now, if you did something like, starting here, if you drew a resonance structure, like this, and drew yourself a resonance structure, where you bring those down like this, and then use that to go in and grab the water, that would have been just fine as well. Okay. So we are just looking, as we're grading this mechanism part is +5 points. And so the way we graded this is everyone just started with the 5 points, and then we're just making sure you didn't make any mistakes anywhere. And if formal charges, bonds, you know, we're just looking at all the mechanistic rules. And if no mistakes were made, then you got the full points. Okay, as always, I hope that was helpful to you. If you have any questions, please reach out. Be more than happy to help. And here's just a quick glance at the answer choices right here. Okay.